Hello, my name is Stefan Koch, and today we are going to talk again about DLang. And I have a post here in the DLang forum where Attila writes that it takes 120 milliseconds for him to compile a file that just imports std.path. And we are going to take a look at that right now. And we're going to see if that it is. First we see if it is true, and second we will have a look if it's true, why that is. Okay, now we're going to open up a terminal and we're going to compile a file that just imports std.path. And here is a comment which imports the C headers, the headers for the assistant library that we have, and we are going, and it's just a comment, it's just there so we have something to compare it to. So first of all we're going to compile this file that just imports std.path, and we're going to take a look at how long it takes. And we see that it takes for us over 200 milliseconds, which is worse than what Attila had, but that's probably due to hardware differences. Now, and he also hasn't said which compiler he used for this, which we will later see can well, of course, have an effect, but it also affects which version of the standard library and of the runtime library he uses and what the compiler does for string switches, for example. To compare this, we are going to import the header files for string, stdlib, and stdio. And we see that this takes 9 milliseconds in the user process time, about 13 for the system, and that's probably because we read a file, and as soon as we read a file we need to take a global lock, and that can take time, of course, as things do in our multi-threaded and multitasking systems. You can never be sure what's actually going on, and there's always some synchronization overhead involved. So we see now that that is a totally reasonable time, and yeah, again, this is in contrast to 200 milliseconds over here. We are now going to take a look at the actual std.path, and we're going to look at why this could be. So, std.path is a file that has 4,000 lines. Most of them are comments and documentation, and a few tests, a lot of unit tests actually. And unit tests are not compiled unless you actually compile with the unit test flag on, so they will probably not affect us. But there is something else we can see in here, and that is somebody is using templates and template constraints, which then instantiate templates. I mean, to people who know the D programming language and who are familiar with Phobos, they know once they see standard traits or standard meta, the times of fast compiling your code are gone now, right? Because they contain recursive templates that need a huge number of instances to properly work, and that's the cursory analysis of this. Now, you might be saying, Stefan, we all know that you don't like templates because they can have this effect on performance. But how do you know that this is actually the case here? And I am glad that you asked me, because I have a tool that can tell you how long something actually takes to work with. And we are going to open this file again, which we have, which just imports the stat strings, stat.lib. And we're going to use a modified version of DMB, which creates a special file called symbol.log, which tells us how much time a particular symbol in the compiler took. So compile, we can time it. You see that this takes longer than the vanilla DMD, and that's because it wrote out a file, which is this one. We have a file here that tells us which symbols were processed. We see what we think we should see in here, and those are just a number of function declarations. This is all relatively tame. So one of the biggest functions, I guess, we see here in terms of time it takes, those are the ticks, the actual function takes, and those are not separated, so a module gets counted as the sum of its parts. That's why the modules and the imports have so large numbers, because those are inclusive of the children, right? Those are not exclusive counts, those are inclusive counts, and that's why they look the way they did. But what we can do is put this file through sort, then we see how long the longest modules take, and that should usually be the module that you are currently compiling. Then comes object, and then come the other modules. And then after the modules, here we have functions that probably import something themselves, and yeah, they probably import those modules. And after that, we basically get totally reasonable numbers for the time those functions take to process. Now we are going to change, the file we created, and we import std.path. And we run the same tool on it. Again, it takes a bit longer than it took without the creation of the symbol list. And we're going to take a look at this. First, unsorted. We have object, we we have toString, we have runtime info, blah blah blah. This is all stuff defined in object. We can't really get away from this, and we see that a few CTOR declarations take time and exception. This is all not crazy, so this is all still in the normal in normal ranges that something can take to process. Let's now sort this symbol list and see which symbols are in there which take very long. And since those are inclusive timings, it doesn't necessarily mean that those have a problem. If they import something else which also takes long to process, then you will see that. So first comes the parent module that has everything else under it. That takes the longest, of course. Then importing std.path, which takes almost all of the time, and it should, because it's the only thing the module does. And that imports time zone and systime, which take pretty long. I guess that, yeah, systime is imported by file, and time zone is imported by systime, and time zone takes a long time. Then we have uni and the Unicode tables, which take a long time to be processed. Those are all modules and imports. We expect that those take a long time. Then we have a template instance here. And maybe this template instance is dependent on other modules, which also would explain why it takes a long time. Let's just take a look at this file at 5628. Oh, and what we see here is something that calls has indirections on T. And for that we need to know what T is in this case. We should actually be able to read what T is. T is this looks like another template. I don't have TD Mango. Well, then it doesn't really matter too much, but would have been interesting. But you see that this one has directions is already something that is a problem, and this is in the forwards module standard traits. No, has directions as in standard type cons, and he satisfies and standard traits, which is probably common. Oh, here we can read up what it is. It's a standard.file iterator, which takes time to process because we are importing standard.file inside of standard.path. And if that is indeed the main problem here, that we import standard.file, we should be able to reproduce our long compile times by importing standard.file. And indeed, we can do this. Right? Those are almost the same timing. So it's not std.file that takes so long to compile. It's not std.path. It's std.file that's the problem. So let's now look at the simple log of just importing std.file. We sort this. Not reverse, please. There we go. And there we can see the main problem seems to be the module time zone in standard.datetime.time zone. This is the one that takes the longest in here, and we can see where this goes by just importing and we need to remove the decal. No. And this also takes almost 200 milliseconds. So this means that the main problem, we have narrowed it down to time zone. We want to know which symbols in time zone takes the most time to compile. So we're going to check that now by running our sort n simple log. And are we still importing file? No, we're just importing time zone. Maybe we didn't write the simple log correctly. And we see that time zone doesn't import too much things. Well, itself imports standard.uni, which takes a major time here. So let's see what happens if we import standard.uni. And let's have a look at the symbols here. And just let's see the time. So those are 180. We already lost almost 100 milliseconds, which were used by something else in there. And now we can start getting at the biggest, at the functions and things that take the longest time inside that module. And here we can see that almost all the time is used by the word character function, which is presumably because inside of the word character function there are some things in there that is not nice and take a long time. And we can see here one of the symbols that takes very long is actually the T inversion list. That takes time. And another one are the Unicode tables, but the Unicode tables themselves take, in comparison, not all that much time. So that's not the problem. I would say that those template instances probably are not too nice, and we have here template with a name generic index of, which takes about 1, 2, 3, 4, 5, 6, 7, 8 type parameters, I guess. And that is a problem. And then the module also imports format and uses trace, which actually, let me check what it imports here. This also takes a lot of time, but most of the time it's actually taken up here and here. Those take almost all of the time. So let's check those. 1976. And this is the code line that takes the most time in the whole file. An inversion list predicated on GC policy. And I don't know where the inversion list comes from. Maybe we'll find that out later. But you can see we already narrowed it in version. I thought I would have seen it here. Yeah. Version list. There it is. It's a template. Which does what exactly? It itself instantiates the intervals template with, oh no, that's just the unit test. It shouldn't be the problem here. Probably the cow array. Oh, is forward range. It's getting called here as well. So it's presumably one of those templates that take the most time here. So this is basically how you analyze what actually takes time in a module. In this case, is that std.path depends on standard.uni, which probably is unnecessary. So that would be a point where optimization could focus. And this is less about compiler internals and more about the deep coupling in the Phobos library. Yeah, that's all I have to say on that. Where is